Welcome and thank you for joining me for another episode of the Water Connections webinar series. I'm your host, Richard Restuccia, and today we're going to be talking about smart irrigation. Of course, it's Smart Irrigation Month. It is Wear Your Blue Wednesday for Smart Irrigation Month. More importantly, though, with smart irrigation, I wanted to talk about smart controllers today. And in particular, we're going to be talking about B-hyve smart controllers, which are an excellent choice for residential landscapes in particular. I've been very surprised as I've learned about B-hyve controllers, all that they do for the users. It's incredible the amount of data and technical and weather information you get in your B-hyve controllers. And when I started to learn this a little bit more right away, I reached out to Brad Wardle. Brad has been he's really one of the founders of the B-hyve product. And I reached out to him initially and said, listen, we really need to show our audience what you're doing because really you guys have a great product at a very good price point. So Brad was happy to join us. You know, Brad's been at Orbit since 2001. He's been passionate about irrigation for his entire life. If you read his bio, you notice that when he was young, he used to hook up sprinklers to a kitchen timer to turn them on and off. And boy, I hope he tells us a little bit about that today, because that is really interesting. You know, Brad served on boards, received industry certifications. And like I said, when I think of founder of B-hyve, Smart Irrigation, this is the person I think of. And certainly there's others on his team, but Brad has really been the significant push for this product and this technology. Brad, welcome and thanks for joining us today.
So good to be with you, Richard. I'm excited, I'm happy, and I love talking about water. So looking forward to it. This is a fun time.
Yeah, great. So, Brad, I think the one thing we need to start out with is, you know, there's a lot of different opinions or definitions of what a smart irrigation timer is. Can you start us off and in your words, tell us what is a smart irrigation timer or a smart controller?
Well, that's a great question. And we typically look at smart controllers in two ways. And I'm going to go ahead and just share my screen now so that it's up and we're going. Let me get it going here. Just one second.
And Brad, if you have some time too today, we want to hear about those impacts working with the kitchen timer too. So, okay, great. We can see your screen there.
All right, trying to get to the right slide.
Yeah.
All right, here we go. Okay, you can see that okay?
Yep, it's in presentation mode. So thank you.
Beautiful. All right. Well, when we talk about smart irrigation controllers, there's two versions of smart that people think of. If you think of smart, you may think of your phone, something that connects to your phone. The other way we talk about irrigation controllers is smart, being that they connect to the weather. They're going to adjust all season long for you. They look at what's happening. They adjust based on rain, based on, you know, high temperatures. We're having 104 here in Utah. They'll account for that. They'll look at the higher ET and they'll adjust. So when we talk about smart controllers, we talk about it in both ways. Connected, which people do love, having a phone connection to their irrigation controller. You can control it from anywhere in the world, essentially. And you can see what's happening from anywhere in the world. Also, more importantly, you can also take that and share it with neighbors. One of the things that didn't happen before was you had to share your garage access code or a key to your home for a neighbor to go in and adjust your sprinkler controller if there was something wrong while you were out of town. But you can do that remotely as well. So smart controllers, we'll talk about today less in the connected mode of to your phone, but more in terms of connecting to weather, looking at what's happening in the environment, and constantly adjusting based on environmental factors. And that's what B-hyve does. I typically talk about the problem in watering with these two numbers. So you can see 25 and 50. I asked this question to folks, what do you think those numbers mean? It's not the year that we'll finally be out of water. That was one question I got at one point. But 25 inches is typically what the lawn, at least in this area, needs in a year. 25 inches of water. 50 is the amount that people apply. So you can see this is the problem. Herein lies the problem that we have with watering. And with really the bad rap that people get for lawns, for example, is just the amount that they're using. Now, I don't think that anyone wants to waste water and wants to water more than, double what they need. I don't think that people are out trying to drain reservoirs, for example. But the question has always come up, and I've gotten this question for over 20 years. How long should I water and how often should I water? And those questions get answered very quickly with a B-hyve Smart Timer. So we'll dive into that a little bit today. And I'll just show you, Richard, a couple of the things that, what is a smart controller? I'm going to talk about just a couple of B-hyve pieces of what you can do with Smart.
Yes, Brad,
yeah,
I just want to interrupt a second, sorry, but I did want to let everybody know we've got the Q&A open. So if you put your questions in there, I'll pass those on to Brad where appropriate. And we really want to encourage you to ask questions today. And then we already had a question, Brad. And that first question is, why on that slide, right, 25 inches in Salt Lake needed, closer to 47 inches here in Southern Cal, where I live, needed a year. Why are people watering double the amount? What is causing that?
Yeah, it really goes back to the question that I mentioned, is how long and how often should I water? So what people will do is traditionally they'll get a controller, they'll put a program in, a traditional non-smart controller. They'll set up a program. That program may be everyday watering. Maybe they set it for July watering. We're in July. It's hotter than the blazes out right now. And ET is sky high. We've got a reference ET of 1/3 of an inch of water being lost every day through evapotranspiration. So people might be setting their clock for July and letting it run from April to October in Utah in a July mode. Now clocks have tools and features that a user can go adjust, budgeting, for example. They can go set up another program. But typically what we see is most people leave their controllers alone. So it really is just something that a consumer, they might set it up for every day, every other day is typically what we see. And they turn it on every other day starting in April. They turn it off, still going every other day in October. Or maybe they don't even turn it off at all, but they turn off the valve to the water supply feeding the irrigation system. And really, this is what happens. This is what I've seen. April 13th, a number of years ago, just to get to the 2550 question, I was leaving for work. I have a bad habit of taking photos of people watering in the rain. We had a great torrential downpour and I drove past a neighbor's house, great individual. Again, I don't think they're maliciously watering. And he was watering his lawn. Well, what happens is once they pressurize the irrigation system here, because we have secondary, the sprinkler timer was never turned off. It just starts watering again. And so this is really gets to the heart of why people are watering more than double is they've got a setting in a controller. It's probably every other day. The water comes on. It's April 15th. It's raining or snowing outside, and their water came on, and they're still watering. So really, it is a question of how long and how often that people just don't understand. The beauty about smart controllers across the board from every manufacturer is they are raising awareness for what people should be doing with their watering systems. So.
Yeah, so Brad, I want to ask you this, back 20 years ago when you first started, I think the industry taught things like set your controller to what it needs to water in July. And then at some point in the fall, reduce it 25%. In the winter, reduce it to 50%. In the spring, take it back to 75, and then back in July, back to 100%, which is 4 adjustments in a year.
Yeah.
How many adjustments does a B-hyve smart controller do in a year?
It does more than double that a day.
Yeah.
So it is constantly adjusting, and that is, we've surveyed customers over the years of how many people actually go put a clock in a rain delay when there's a non-smart timer into a rain delay, manually pressing the button on their timer, and we see that it ranges from 1% to 3% of people. So definitely a huge smart controllers have been a huge leap forward in raising the awareness and giving the users, the end consumers, tools to water smarter.
Right. So if I understand that correctly, there's no way a user could adjust their clock multiple times a day or once a day. I mean, there's just not, time doesn't allow it, life doesn't allow it. So it's not really a user issue. It's just this technology allows us to do this.
Yeah, technology has really made it so much easier for everyone.
Great, thank you.
Absolutely. One of the challenges we've been talking, I've mentioned 104 degrees in Utah, and we've seen drought across the West over the last, decade growing. You see a lot more drought. B-hyve a number of years ago, because smart controllers are smart. They connect to weather, they connect to your phone, but they have limitations. Some of those limitations are if ET goes up, you see ETs going higher, they want to water more. They want to water more. They want to compensate for a higher ET by watering more. One of the challenges we've seen with water providers is that when drought settings or when droughts kick in, they want to go to prescribed days, 3 days a week, for example, and people start taking their controllers out of a smart weather adjusted mode and putting it into a prescribed 3-day-a-week watering. We also see then people watering longer times on those days because they've got to get it all in. And so we introduced drought settings. This is just a fun thing that, again, you can do with a smart controller. You can go into a zone. You can click into the zone. You'll see at the bottom, there's a drought settings feature there. And then based on the location of the timer, it will pull up the US drought monitor map for your area, which is really cool. And then you can even click on your county and see what level of setting you're in. You can see on my map, I pulled 2021. We've been climbing out of it a little bit since then, which was an exceptional drought for my area. Now, what that does is it reduces the impact of ET. So I don't have a 0.33 inch reference ET anymore. I've reduced that by 75%, plus taking out the other factors for my landscape ET as well. So drought has been a fun feature we've introduced. We also went one step further. And again, we're talking about smart controllers today. We're talking about how great they are. I'm also wanting to talk about some of their limitations. One of their limitations is that they all use a prescribed application rate for a sprinkler type. You go in and select sprays, it'll give you 1.75, 1.5 inches per hour application rate. This is all great, with all of us manufacturers setting up heads in a room and testing, and we get these clean numbers. Well, the real world does a lot of things to those clean environments, and a lot of nozzles get changed over the years. A lot of equipment gets changed. Maybe the spacing is off. And so what happens is we see that really an irrigation audit is the best way to compensate for that. So what is an irrigation audit? If you haven't taken the CLIA course with the Irrigation Association, essentially you're going and putting catch cups out in the yard, you're running the zone, you're seeing how much water is in the catch cup, and it's giving you an application rate for that zone. All of these screens are built into B-hyve. This actually did win an award with the IA a number of years ago. But you put those catch cup volumes right in, it will spit out an application rate, tell you some of the details that you do in your CLIA testing. They're including your distribution uniformity. Now, these are all fake. My DU is not this bad at my house. Well, it might be, but these are faked numbers here on a zone, and but it'll give you that. But I want to show you this in real practice with a short video. And this is a great demonstration of what this does and why this is like really, if you get a check engine light in your car, you might think you know what it is, but you really don't know until you hook it up to a computer. You might think you know your application rate, but you really don't know until you do a catch cup test.
Hello, I'm Natalie Irie. I'm in my yard and I'm going to show you how you can use B-hyve to save water. I arranged the cups about 3 feet away from each head and then also in between the heads. And now through my B-hyve app, I'm going to run a test for each of the zones for about 5 minutes. So now we're going to input how much water is in each one of these cups. So in the B-hyve app, you can just put that right in. Okay, I'm now looking at my results from this test, and the application rate was 1.2 inches per hour, which is really high for these kind of rotors. And instead of doing 15 minutes of watering, it will now be cut down to 20 minutes of watering. And it used to be I was using 1,000 gallons of water every time that I watered, but now using B-hyve, I will only be using 400 gallons of water. This will cut down on my water bill 60%. Thank you, B-hyve.
What a great video, Brad. Thank you for sharing that. And I'll tell you, we just got a wealth of questions that came in on this. First question is this: do you have to run this catch can test to use the B-hyve controller?
You do not have to run a catch cup test to use the B-hyve controller. B-hyve does what other smart controllers will do. You select a head type, it gives you an application rate. If that application rate is wrong or it's different than that, maybe instead of rotors, you have rotator nozzles. You can go in, there's an easy slider. You can just adjust the application rate with a slider within the settings for that specific zone.
Yeah, and I tell you, I did take the CLIA test many years ago. It was a 2-day class at Cal Poly San Luis Obispo. It was a great class, and probably one of the most significant, this was early in my career in irrigation, but significant things was it really helps you understand that not every head is set in the right place or doesn't stay in the right place, or not every sprinkler is giving the same amount of water as the one next to it. And visually, I thought that video captured that very well. But one of the questions we have coming in is 68% efficiency, I think was the score on that. What does that mean?
That's how efficiently the water is being distributed across that area. 68% efficiency is pretty good. It's pretty, a rotor can achieve that pretty well, and it's not too out of character for a rotor to do that. Sprays can oftentimes be a little less. Drip, of course, point source watering is really the most efficient, but it's how efficiently the water is being spread over that area. Now, just to talk about efficiency, because that is an important point, we actually will, because efficiencies can really swing a smart timer's runtime, we actually default our efficiency, even if you've got a bad DU on a catch cup test, we default it to 75% and make the user go into advanced settings and change that. What could happen is if you took my 37% efficiency and you use that, you would be watering double the amount of time that you need to compensate for a lack of even watering across that area. But with the capillary effect of soil, slope, different things, oftentimes those are really mitigated by the fact that water does move around in the space.
Yeah, so if my garden, Brad, just to make the math easy, needed an inch of water today, but my efficiency was 50, I'd have to really water 2 inches to get that 1 inch.
Exactly.
Yeah. So, wow. Okay. So that really helps us understand, right, how much we're actually going to be wasting. Okay. All right. Great. Thank you.
Very good. Well, just to dive in then, we've been talking, Richard, about weather. We've been talking about smart controllers adjusting for the weather. This is just a quick look at a B-hyve smart controller, and most of them do something similar to this, in the sense that we're looking at it a 2-week forecast. You can see this is a May screenshot. There was no watering scheduled for these 2 weeks, which is fantastic. Again, our water turns on April 15th through May 15th, essentially, 0 water. April 15 to May 15, 0 water. Again, I'm going back to that homeowner we talked about in the very beginning, right? They've just let their controller run all year. There just wasn't water on for it to be spraying, but the water came on April 15th. They've been watering every day or every other day. Maybe they've watered 15 times in the spring when it's raining and snowing, and there's absolutely no need. So this is really where you can find a lot of savings. These tells of the season, April, May for Utah, and these are different regionally dependent, but April, May, September, October, you can find a ton of savings by letting smart do its thing, by letting the weather adjust the controller. There's the example on the right side, 47 degrees for a high, 34 for a low. If your freeze settings on your B-hyve controller, because we have rain, wind, and freeze, if your freeze settings were set to 37 degrees, you would kick into a freeze delay. It could be a rain delay, could be a freeze delay. Either one of those would work in the sense that you do not need to water. Those times get pushed out, and really you can save a lot of water in that early part of the season.
So, Brad, I get how it's the irrigation's either on or off, but how does the technology work so that I know how long to run, as you mentioned earlier, and how frequently?
Yeah, so we're essentially taking it. I like to tell people to imagine a kid's swimming pool on their back patio. It's sitting there, I fill it up, my kids use it, water gets lost. A week later, it's evaporated out, maybe 1/3 of an inch a day. A week later, it's even lower. Suddenly I have essentially an unusable kid's pool. Well, your soil is essentially a big reservoir doing the same thing. It is filling, draining, filling, draining. What can fill it? Well, you can fill it from irrigation, or you can fill it from rain, Mother Nature's way. and it's filling it up. So we calculate both of those. As it's draining, we get to a point that plants can no longer access the water. So we're really just filling this readily available water piece of this, and we're playing within that space. And it's not a lot of water really that the plants have access to. 0.42 inches in my clay loam soil is what I've got. So I'm refilling 0.42 inches every time I water. So.
Yeah, that's interesting and very helpful, right? Because that's, for those of us that don't get a lot of rain in May and June, I wanted to know how that actually adjusted for us. Now, we've got another question coming in, Brad, on the catch cups.
Yep.
This question is about setting baselines. When I enter all of the requested data into my B-hyve program, it wants to use several thousand gallons a week. I've had to play with the variables to get it down to 600 gallons or so per week, but that's just by guessing. And by the way, I did use the catch cups, but they're still feeling like that's a lot of water, 600 gallons a week. What do you think?
Yeah, well, with all things, there are a lot of variables that we put into a smart controller that are pretty absolute. Soil type, fairly absolute. Root zone depth, fairly absolute. We're building a profile that's a very static, if you will, image of what's happening in a very dynamic space, right? So, and that could be years of really taking care of the soil. It could have been a garden before there was lawn there. Could be hard packed, and you're losing water in, the first 2 minutes of a spray running. Everything else is just sheeting off. There's so many different variables that go into it. There's that part of your lawn that just no matter what you do, it gets yellow when it gets hot every year, and you try to amend that and make up for that. So I think if you've done a catch cup test and you're getting more water than you want, we have a great setting in the app. I don't have a screenshot of it here. Well, I actually might. Let me go back up. I do believe I have it. Let me show you right there on the smart details with all of the soil type, plant type. There's a schedule adjustment screen right there. You can go in and you can take whatever smart is telling you that it thinks it wants based on all the inputs you gave it, and you can go adjust the frequency and the duration right there in that screen. It will still stay in a smart mode. It's just adjusting the inputs to the point that it's changing the application rate. It's changing the efficiency. It's changing some things in there that are going to offset what it thought it wanted to do. So if you say, okay, I did a catch cup test, it's wanting me to water 20 minutes, I think 15 gets me there, you can go into schedule adjustments, adjust the slider, super, super simple, and it's still running in a smart mode. It's just been given new variables to work with. So really easy way to do that if catch cups are taking a little more water than you think. But like in the example, and I have to thank Stuart Eyring, who was on here last week, and his daughter for that great video. Like that example showed, a 600-gallon save, because that was a rotor zone. Now rotors in a typical smart controller, they get put in. If you go just hit a rotor for a zone, the typical smart controller says anywhere from 0.5 inches per hour application to 0.75 inches per hour application. He came in at 1.2 on that zone. So you can see that just what it does is it gives you a real look into what that check engine light really means and gives you the opportunity to save. Now, sometimes, to the question that was asked, sometimes that water use might go up. You might have been underwatering, but again, you can dial it back with some of the schedule adjustments in there.
Yeah, and thanks, Brad. It's really interesting too, because 600 gallons might sound like a lot, but I'm looking at those rotors behind you, and they might be putting out 20 gallons a minute, right? It's conceivable that they're throwing that much water. So one rotor, 30 minutes would be 600 gallons. And I mean, there's probably 6 or 8 rotors on that zone. So 600 sounds, again, depending on the size of the property, pretty conservative.
Yep. But it does add up. That's one zone of, maybe a 12 zone system. If you multiply that across the whole system, you get a lot of savings. And then you do that day after day after day after day, and it really does add up. So we do believe in, counting every drop. And certainly this is a way that you can do that.
Yeah. Okay, great.
Let me jump past our video there. Jump past these. I guess, one of the questions that comes up is, That's good in theory. Does it really work? Well, I'm going to just show one example. This is my own controller at my own home. So we talked about controllers, non-smart controllers, typically not getting put into a rain delay. This is one rainstorm that happened in Utah in August. So August is typically a very hot month. July, smart irrigation month, is cooking. August is not far behind it in Utah. And what we saw was this great rainstorm came in. And after a few days of it raining, I looked at my controller, or I pulled open my B-hyve app to see what was going to happen. And I got this screen, and it's a beautiful screen. My next watering is in 10 days. And it followed that. And as we looked back at the storm and we looked at what happened, it was fantastic to see I didn't water for 2 weeks in August. So if you were an every other day water, that's 7 waterings. We'll just say I'm about 3,000 gallons of watering. So 21,000 gallons extra that would have been used if I was in probably a traditional controller, up to if I was watering every day, which a lot of people do, water every day in the summer in Utah. I might have watered 42,000 gallons in the same time that I put down 0. Now just take that and multiply that by every residence, and it just adds up so quickly. Let me just show you some of the stats behind that. 600 million gallons saved in one August rain event across the state of Utah with B-hyve controllers. We saw that 80% of all of our timers in the state were in an automated rain delay, meaning the user didn't have to put it in rain delay. It was the system generated the rain delay based on the weather, which is just incredible. Again, contrasting that with the less than 3% of non-smart controllers going into a rain delay. That's just huge savings. And then of course, when you start to play with those big numbers, and you take that across the ecosystem, or you take that across, I should say, the state, or wherever you live, the city, the opportunities for savings are just off the charts. 3 billion gallon saving easily achievable with one rainstorm with smart controllers. So just absolutely huge results.
Yeah, these numbers are really impressive, Brad. And when you think about places across the U.S. that do have consistent rainfall all summer long, right? The beautiful summer rainstorms, might as well use all that free irrigation for your garden and for your landscape, and not be supplemental watering.
That's exactly right. That's exactly right. Yep. And we, the great thing about what we do, and I know ET Water is deep in the same methodology, is we look at the storm. So B-hyve sees a storm coming. If your parameters are set to 40% chance of rain and a 1/16 of an inch before my system shuts off, great. It'll take those into account. You can adjust those for your area. But once it's shut off for the rain, it's going to look back and see how much rain fell. Remember my pool analogy. It's filling up the pool. It's filling up the soil reservoir. And so it's going to look back to see how much of that reservoir was filled from the rainstorm. If it wasn't filled enough, you might get back into a watering cycle fairly soon. If it was filled, you have then the benefit of days and days and days, in my case in August, 14 days, where I didn't need to water. Now, a question that may come up, I haven't looked at any of the questions here, Richard, but a question that may come up is, do we take into account all of the rain as if we can use all of that? The short answer is no. We only use a usable portion of the rain plus a percentage beyond that that we would attribute for the rainstorm. So if you're in parched earth, dry Phoenix, Arizona, maybe sandstone, southern Utah, 3 inches of rain ends up in riverbeds very quickly and ends up not usable very quickly. We don't count the 3 inches. We only count really usable rainfall with a little bit of extra that accounts for some of that actually percolating through the soil. So.
Wow, so that's really unique, because I've seen some other smart controllers, and they say after a rain, how long do you want us to wait until we start irrigating again? And I think, well, how would you even know until you figured out how much it rained and what the usable was? So yeah, that's good to know that the B-hyve controller can actually figure that out for you based on the actual rainfall.
Yep.
Wow.
Yep, absolutely. And it takes that guesswork out, like we started with. We want to take the guesswork out for people. We want smart watering to be something that everyone can do, and that everyone can apply in their yard and not have to keep guessing all these years later. I guessed enough as a kid. I'm done guessing. I put my timer in smart mode and I let it go, and I look back at the season to see how I did, and I'm always pleased with the results.
Yeah.
One of the questions, Richard, that we've talked about a lot in the industry is that actual number that you apply. I'm not going to go through the math behind how much water gets applied every time someone waters. The math is really good. In fact, I'm cheating a little bit on the low side. I know some people use a lot more. I do know some people use less. But this is a picture of a tank. And I always ask people, I've done lots of trainings, as I mentioned, and I love to ask the same question: how much water do you think you use every time you water? I'm going to just list the results that I get. This is the most common one: 50 gallons. Every time I water my whole quarter-acre yard, people say 50 gallons. Okay. Next, they go 150. Next most popular, 300 gallons. Beyond that, 5, 1,000, and 15, and 25. This is a 2,500 gallon tank. I wish there was a person standing next to it for size reference, but this is a 2,500 gallon tank. And you can see that's how much water you're applying every time you go irrigate. So why are we obsessing about a rain delay, for example? Because if you don't shut off for that rain delay, you're missing the benefit of the rain and you're applying out of the reservoir. You're applying 2,500 gallons of water that's just unnecessarily. And if people see how much water that is, they kind of go, oh, that's a little more than I thought. But I like to translate these things into real world scenarios. So here you go. What does that mean at home? Well, 2,500 gallons, that's a year's worth of toilet flushes. So if you've got a 1.5 gallons per flush toilet, that's about 4.5 flushes a day to get to 1 day of not watering your lawn. So while we believe in a multi-pronged approach to water savings, including low flow toilets, including low flow showers, well, I sort of don't disagree. I sort of don't like low flow showers, but that's another story for another day. But if we take this multi-pronged approach, really, if you can turn off your irrigation system 1 day, 2 days, 3 days, 10 days in the spring, maybe 5 days in the fall, you've just gotten, the water savings are just off the charts. You've gotten so much in water savings that literally it takes you 1 day to equal a year of toilet flushes. So again, put this in real world terms. People can translate that back to their residents in their district or to their homeowners they're working with as a contractor, or whoever it is. That's the importance there. And that really is a message that does need to get out.
Yeah, this is a great illustration here, Brad. I know they used to say often in Southern California, a 10% reduction in landscape water use is the equivalent of reducing toilet water use to 0. This even makes a bigger example here of what 1 day of watering takes.
Very good. Clipping along, I like to take that 2,500 gallons and then apply it to the year. So what does it mean for my entire year? Here's a simple graphic. Now, I'll just say at first pass, Smart may adjust differently than this. This is really a historical ET number, and we are seeing ETs creep up a little bit higher. June in Utah, we had a higher ET than last June, for example. So historical ET, this is the kind of numbers you're seeing. And so where you start to see the savings in all of this, let's roll it up for everyone. You see an every other day water that's got 180 days in an irrigation season. They're going to water every other day. There's 90 watering days. A smart controller following the weather, and again, it may adjust more or less than this. You may see that differently than this, but this is really kind of the profile that it can follow. Particularly when I leave mine alone, mine follows more of this profile, and you'll see that I'm up to about 48 watering days, or a 47% reduction in my water use, or in my days. So, and I haven't even taken into account rain delays. So this doesn't include rain delays. This is just if I'm smart watering and I can get all of these savings plus rain delays. If I'm at 2,500 gallons a pop, 225,000 gallons used, that's actually very close to what our allotments in Utah are for secondary irrigation on a quarter acre, is 225,000 gallons. My original slide started with 25 and 50. That's really where you can get your savings right there in a smart watering mode, which is fantastic. Again, this is perfect world. I know the real world does crazy things to perfect ideas, but at the end of the day, 47% with rain delays is just phenomenal.
Yeah, so Brad, a couple things here. The 2,500 gallons per day, right? We saw the big water tank. This is for an average size lot,
Yeah, quarter acre lot.
quarter acre lot, right? So if you had a full acre, it'd be more, it'd be four times that. If you had
Mhm.
small, it'd be okay.
Yeah,
Okay, great. Just want to establish that. Couple other questions coming in.
great.
The timer is the brain of the system, right? But oftentimes, even with a smart timer, we'll see dry spots in your yard, which probably are due to other irrigation emission device issues, not the smart timer. How do you address this?
That's a great question, and we see it pop up every year. And your lawn can be looking like, Vancouver Island, through the spring, and then suddenly the heat hits, and it looks like trash. It just looks terrible. And I look all at the lawns all around here, and I see that all the time. Um, the the right way to address it is obviously to find out what's going on with the equipment. Check the equipment, check for tip nozzles. A lot of times just a little seed or a little rock in a nozzle will create a V. Suddenly you're not watering the spot anymore, and if you don't have head-to-head coverage, it's exacerbated even further. So checking equipment, checking for tip nozzles, checking for clogged nozzles, and then really checking what's underneath that lawn. The lawn is manifesting things that are going on below the ground. Sometimes you can't see those. You can see the sprinklers, but you don't know if the contractor, when he left, he put all the road base there. You don't know if that was the concrete clean out that just keeps manifesting problems year after year. So really getting underneath the level, the ground level, to find out what's going on and addressing it there. Spot watering, one of the things that is not, it's almost heresy in our industry to talk about watering from a hose faucet. But it's one way that we can do it is we can take a faucet timer, put a hose on that one spot, and instead of watering that whole zone that's pumping out 400 gallons in a watering, we can just spot water that area and do it that way. So those are the things that I see, if that answers the question. And
Yeah. Yeah, that's great. Thank you. And then next question coming in, Brad, is about soil moisture sensors. Does B-hyve use soil moisture sensors? Why not? And what about the accuracy?
yeah, great question. I'll give the where we've been, not where we're going. I'll just talk about where we've been. Soil moisture sensors is a very talked about item, and a lot of people say that's the way to go. I've seen sensors that work well. I've seen sensors that don't work well. I've seen sensors that get confused about what they're reading. I will just say this. Soil moisture sensors in and of themselves, I think, are fine. I think they're great. One of the challenges is where do you put that sensor? That's always been one that comes up. Do I put it at the top of the slope, bottom of the slope? Then I start talking about, do I get multiple sensors? Do I put it under the tree? Do I put it in full sun where it's drying out quicker? And then again, quantity. Do I put it in one zone that accounts for all my zones in my yard, or do I have to put one in every zone? So soil moisture sensors are great. The complexities when you get below great are a little bit more. But you can hook a soil moisture sensor to a beehive and interrupt it, much like you would a rain sensor in that regard. Now, in terms of what we do, the algorithms are so good and so tested that at this point, algorithm based, weather station based watering is very, very good. And as our company and other manufacturers have refined and refined and refined, it's gotten really to the point that it's exceptional. That if you went out and took the settings in my controller and took a soil moisture sensor, you would see that the two are playing nicely, very, very well together without the soil moisture sensor. Now, I don't think that's the future. Like I said, I think down the road, you'll see more and more soil moisture sensors. I think you'll see devices that are going to make that easier. Wires have always been a problem. Wireless below ground has always been challenging, but there's a lot of great advancements there, and there's a lot of great things happening in the space. And I think you'll see more and more of those become more useful than they've been.
Yeah, I got to tell you, with the Doppler radar satellite imaging, the fact that it can tell you it's going to rain starting at 6:30 tonight for an hour and a half, and it's spot on, is just unbelievable.
Yep. Yep. So it's great to see that. Was there another question, Richard?
Yeah, one more was just asking about like flow monitoring or flume integration, things like this. Is that something that's on the radar?
Yeah, so B-hyve a number of years ago actually integrated with Flume. If you go into our B-hyve app, if you go into your account settings, you can see that you can connect to a Flume there. And so you can actually go in and hook a Flume up. If you go to watering history after you've hooked up a Flume, you can see how many gallons you're using for that zone. The API to API integration we have with them then tells Flume how much, what times we watered. They tell us how many gallons we watered. So there's an integration there with Flume, and I definitely think flow generally for a homeowner has been something that's we'll get there when we get there kind of a thing. Don't worry about it. But it's become increasingly more popular to look at flow as an opportunity to save, to alert a homeowner early with a device like a Flume or something else, to alert a homeowner to the fact that they may have a leak. Maybe their water use was higher or lower than they expected. Things you've seen in traditionally commercial spaces with higher end equipment and really expensive flow meters and really expensive clocks is making its way into more of the residential light commercial space. So that's been fun to see that happening, but that integration is already there.
Yeah, very cool. That's going to be exciting. So everybody who has the most up-to-date software has that available.
Yep.
Great. So Brad, I was wondering too, do you have any success stories that you can share with us? Maybe some people that have used B-hyve and saw some significant water savings?
Well, certainly. I talked about the state of Utah and the August storm that we went through that was just fantastic. And 80% of clocks going into a rain delay on their own was just exceptional, and we were just blown away. Seeing so many. Just the quantity was just off the charts. And so that's really really exciting. I will say this that. Even with drought settings, I didn't include the quote from the individual, but one individual left us a review soon after we introduced drought settings saying, I put it into drought settings and I saved more water than I was doing in my prescribed amount that I was given to use. And he said, the health of my lawn improved. So, the ability to use a smart controller and make big changes is really there. I will say that again, don't look at a smart controller as a silver bullet. They do require some fine tuning, like the question that came up earlier on catch cups. There's some fine tuning needed in every smart controller to get it just right. If people will be patient with that process, and I tell people typically 2 weeks to be patient with the process for about 2 weeks, and then they'll see the results really starting to emerge. And what I mean by being patient, don't go, oh, it didn't water today, and I think it should have, and so I'm going to manually water. And so again, we're taking the soil reservoir, we're seeing the manual watering is filling part of it up, then maybe smart watering is delayed another day. Now we can go into any one of our zones and we can adjust our moisture balances up or down. If you put it to 0, it's going to trigger a watering. If you put it all the way up, it's going to say delay watering. It's got a full soil reservoir. So you can artificially go in and tell it that it's full or drained, but letting it do its thing and not fighting with it, too much is really a great way to go. So.
So I think some people are going to be surprised that you use these on in agriculture also.
Absolutely. We really, as we started this journey in 2016 with B-hyve, we really wanted to change the way the world watered from faucet to farm. We didn't want to just focus on landscape irrigation. We wanted to focus on every aspect, as I mentioned earlier, of outdoor water use. And as we all know, outdoor water use accounts for much of our fresh water, and Stuart gave some great details on that last week. I'd recommend anyone go back and listen to that. One of the things that we've done then is we've built products in each of these categories. We've got center pivot controllers. We've got battery operated cellular devices that can go on a row crop on a big or mad valve sitting in an orchard or a vineyard, and you can control those from one place. We talk about our center pivot controller friends in southern Utah. Their operation went from 12 man hours of turning on and off pivots if there was weather or they were going to cut or things like that. That went to less than 1 minute for them to use a B-hyve device to turn off all of their center pivots, which is just incredible. That's 8 million gallons of water not used. I'm not going to call it saved, not used on the farm. So that's just great. You take that into landscape. There's a high station count controller with 2-wire. or 48 zones, 2-wire 63 zones, battery operated controller there as well. And then of course the timers that you see in distributors and retailers all across the world. Beehives are connected in 170 countries. We're super proud of that. We're very humbled by that. And the fact that people have been receptive to smart watering to this level is just incredible. And then on the faucet side, like we talked about earlier, faucet options for really any application. There are places in the US that don't put your underground systems in because they only need a system maybe 1 month out of the year. And faucet watering being smart, being WaterSense certified, you can literally run it just like you would an in-ground system. It will shut off for the rain, do all the same things that an underground irrigation timer would do. So really options for everyone. I'll highlight too. We wanted to make smart watering affordable for everybody. We launched this, what I'll call our best-selling timer in the landscape irrigation controller space at $99. Just fantastic. We launched a version after this one at $59. We wanted to make sure that every budget had access to water smarter, and so we did that. And on the hose tap controller side, we were able to do that as well on the hose tap controller side. You know, for less than $100, you can go in and get a smart controller for your hose tap, which is outstanding. You can nest these side by side. They have flow meters inside of them, which is cool too. You can see how much water you're using off your faucet. You can set it to shut off based on volume instead of just time. If you're filling a trough that you know is 50 gallons or something like that, you can set it to 50 gallons and it will shut off for you. So really, really cool technology that just gives people a lot of options to cut water use.
Yeah, it really is amazing the amount of technology you get for that price.
Yeah.
Your smart timers, do you have any that go more than 16 zones?
We do. We have the HSC, which is modular controller in eight zone modules, and that goes up to 48 zones. And then we have the HSC, which is a two-wire controller that does 63 zones.
Yeah.
So those two, and then with our battery operated controller that has a cell card inside of it, there's a lot of cool things you can do with that, and that will control 8 zones currently from one, and so just tons of options. If you've got that cut wire circumstance in your yard, you've got a median or a roundabout or an island in a parking lot that you've cut the wires when they did some other construction nearby, and you can't run new wires, battery operated controllers are also connected and smart connected and in use in my yard, which I've been loving because I had one of those exact scenarios, and I'm just happy to have it now. I'm elated to have it. So really, really cool.
Yeah. And one last thing, the water agencies, they're giving rebates on these smart controllers. Is that right?
Yeah, the water districts, most of the West has some form of a rebate. I'll speak to Utah's rebate specifically. Utah has a $75 rebate. I know a lot of California water districts have $200 in the SoCal Water District. Colorado, Aurora, and others out there, they have up to $200 rebates for the equipment only, not labor. Some of the commercially installed controllers have a $1,500 rebate. So there's great incentives to get into them. And the incentives have absolutely been, really helped consumers to pay attention and to not just be content with what's been sitting on the wall for 10 years. Unfortunately, we make great timers. They sit there for, everyone makes great timers. They sit there for 10, 15, 20 years. And so incentivizing a customer with a little bit to make the change has really, really just been huge to increase adoption of smart controllers. I've got up on the slide in front of us, how inexpensive it is for water districts and state agencies to reimburse these. Like I said, for Utah, $75 for a smart irrigation controller. And really the efficacy of a smart irrigation controller we've talked about today, tons of savings opportunities. Another thing that's gaining a lot of traction is lawn replacement. And like I said, we absolutely agree with and believe in a multi-pronged approach. This is at $3 a square foot, which is common in Utah. I know some have more than $3 a square foot. Some have less, but $3 a square foot for any lawn you tear out. Rip the Strip is the big program in Utah. They would pay me $1,080 to pull out my park strip, leave whatever controller I had on the wall, and that's a lot of money for the state to be paying for a single zone. So 75 versus 180, it's a huge difference. What that leads to is what are the savings from tearing out my strip? What are the savings from a smart controller? And as you can see here, there's a big gap. This is an annual savings. I lowered the number. You saw the slide that I had, over 100,000 gallons save. I said, what if you just say 80,000 gallons? How close do we get to the savings for a park strip with a rip to strip program? And you can see there's a big gap here. Now, people will argue, tear it all out, tear all of the lawn out in the world. We'll talk about that in a second. But you can see the opportunity for savings with a smart controller is huge. And again, lawn replacement, some lawn doesn't make sense. I love that people are starting to say things like, put it in areas that make sense. Don't put it just everywhere because it's easier. Although it is easier than weeding, but this is really just a huge gap in the savings.
Yeah, it sure is. And a couple things I always think about on this, Brad, is when you do a lawn replacement, you change from lawn to maybe some plants. But if you don't change the irrigation devices that are delivering the water, you're still wasting a ton. If you do swap out the irrigation, then you got a pretty high expense to do that. And takes a whole lot more time than just connecting a controller to your already established system. So there's even more to examine here, but the deeper I get into this, the more I think the controller is obviously the way to go, right? You say $3 in Utah, $5 in a square foot in Las Vegas. So over $2 million to pull out 10 acres of turf. I can't imagine where they see that they'll ever get that much water savings.
I don't know, but I'm going to Las Vegas right now to buy some land, Richard. That sounds like a great investment idea. Yeah, it certainly is. Again, I think putting turf in the right areas matters. We are a manufacturer of all types of irrigation equipment, drip systems, mist systems, efficient irrigation systems, PR heads, everything you can think of, we're manufacturing. So we're less inclined to say, hey, we care how you water, or we care what equipment you buy from us, I should say. But certainly when you look at it, if the brain is still non-smart, and you still have all these other zones doing things, I think there's some gaps here. So I think there's an opportunity, and I definitely think, like we've talked about with rain delays, we'll go back to rain or shine. With rain delays, you can absolutely get a massive amount of water savings. Think of the toilet. Think of the big barrel, the 2,500 gallon barrel. And I hope everyone starts to think of that every time they see a cloud or a raindrop on their windshield, and that those become the things that they start looking at and thinking of.
Yeah, very nice. I think we will.
I'll just pass through these. This is the cost. What we just showed you, the savings. Here's the cost per gallon saved. So less than 1/10 of 1 cent for a smart irrigation controller per gallon, and 15 cents per gallon on lawn replacement. Again, that's at $3, and that's at a, but that's just staggering, the differences there. Again, we have to be looking at everything. So I love that we're looking at everything, but certainly smart controllers and where we've come with smart controllers is just big. It's a huge opportunity. We talk about ripping out lawn. I'll just show this slide. I won't talk a whole lot to it, except for I asked the question, why not rip everything out? Why not tear out all the lawn? Why not put rocks in? Well, there are a million reasons. Here are a few: aesthetics, cooling, oxygen production, water filtration, preventing erosion, all of those different things, cleaning the water. It just goes on and on and on, the benefits that are there. And I'll just take one example. I took my grill infrared thermometer. I went out in my yard on one of our 104 days. This is a true story. Went out to the road, went out to check the temperature of the asphalt, to check the temperature of the concrete, to check the temperature of the bark in my beds. The bark in one of my beds, 145 degrees.
Wow.
145 degrees. The lawn, 10 degrees, 14 degrees lower than the ambient temperature. 90 degrees was my lawn. And so just the what a lawn does in terms of cooling, cleaning, all of those things. We certainly like it. Our pets like it, our kids like it, and our eyes really do enjoy it. So.
Yeah, great points, Brad. There's a lot to be examined there. It's not maybe as clear-cut decision as a lot of people make it out to be.
Certainly. So that's it, Richard. What, any other questions come in or any other questions for me?
Yeah, so Brad, this has been wonderful. I want to let everybody know who joined us today that you can shoot us an email, and we're happy to follow up with any additional questions you might have or any additional help. Brad, I thought you did just a fantastic job in really explaining the technology that goes into these smart controllers and helping us understand all that goes into this and how we benefit at a really low cost. So thank you for doing that. I'm looking forward to you coming back next month, right? You're going to be a regular contributor. So I really appreciate that. I want to say thank you to everybody tuning in today. It's really great that you're taking a portion of your day, especially in the middle of the summer, when I know everybody's working so hard in their landscapes to educate yourselves. Remember, you can watch replays of this video, and you can find those videos right now at the hydrorain.com website. And we also will have these posted, the audio, wherever you listen to your favorite podcasts. So one thing that's really cool is to think people are out there working and educating at the same time. That always makes me very encouraged for water savings in the future. We'll be back 2 weeks from today. We're going to be talking about how to use smart control on center pivots for agriculture, right? A lot of people think smart controllers are just for your lawns or residential or commercial landscapes. They're also great for agriculture, and we're going to teach you all about that in a couple weeks. So thanks again, Brad. Really appreciate it.
Thanks for having me, Richard, and thanks everyone for being here. Looking forward to that center pivot discussion. That's exciting.
Yeah, you bet. Okay. Well, thanks, everybody.
Thank you.